Hey there, fourth grade scientists. Mr. Height back at you. And I wanted to actually look at the data. So I went ahead and finished my trials. Um, but I do want to show you if you round to the nearest second versus not rounding to the nearest second, what that actually looks like and what that can tell us. Um, Data came out pretty cool. I know it came out consistent, which is good. That means I followed all the rules and the constants. I didn't change anything. So that gave me good data in my group if I was like group one book. So all the other groups would also need to follow those constant rules, and they will also have good data. And then when you all come back and share your class data, you'll be able to answer that question: does the height of the ramp um, affect the speed of the marble? So I'm going to go ahead and go over to my camera, and we'll just take a real quick look. There we go. So you can see I did my 4 trials. Remember, I marked the distance as 100. And yes, it does help to have zeros. Makes the math a lot easier. So originally I did round to the nearest second. So and in parentheses is what the original time was. So 3.76, 3.52, 3.89, 3.72. Okay, so I even put those in there in case you don't round. Very interesting, um, depending on your class or what you want to do. With this particular project, it might be cool to see both. So you can see very easy because 100 divided by 4, 25 centimeters per second. And then over here to the side, it went ahead and divided without rounding. So you can see it does fluctuate a little bit, which is kind of cool because it does show you something very interesting, which is very relatable to the content. We want you to understand speed is a relation, that speed is related on distance and time. It's very early. I'm still a little tongue-tied. So you can see here, here's my times. Even though, we have some milliseconds going on, it does affect things here very slightly, even if it's off by a centimeter or two. It does show you something very interesting. So notice this one here, 28 centimeters per second, and look at the time, 3.52. Okay, as opposed to this one here, 3.76 and 26.5. So what is that showing you? Is this faster? So 100 centimeters, it took less time on this trial than this one. So obviously 28 centimeters a second is faster, okay? But they're all very close to 25 centimeters per second. But I think it was cool that you could actually see the relationship without rounding. You can see what happens with less time. It is a little faster here. And look at this one, 3.89. So it took a little longer to go 100 centimeters for this trial. And that was a lot closer to 25 centimeters, so 25.7. So that's slower. So I could totally see without rounding to the nearest second why that would be important, because it does show us that relationship. We could see that trial 3 was actually slower than trial 2. But once we add them all together and divide by 4, because we want to see the average speed of all our trials. So I went ahead and did that. So roughly 25 centimeters per second. And I even did it without rounding. So I took these numbers and did it without rounding and got 26.75 centimeters per second. So without rounding and rounding, off by about a centimeter, almost 2 centimeters per second. So not a huge change, but it was very important to see that change within my trials. So sometimes rounding isn't the best answer or the best strategy when you want to be accurate with something like that. But the cool thing, it is very easy to divide with our 100 in here, even if we don't round. So very cool. So you could do both. You could do rounding or not rounding and see how close they are, and you can see within your trials what was happening within your project there. And then obviously you're going to share this final number here with the class, because you are this was one book, right? And I should have put that right here, one book. So I just used one book. So how did this relate and compare to 2 books, 3, 4, 5, and 6 books? Okay, did it get faster, slower? And that's what we're going to do here. When you get to these questions, this is where you're going to need everybody's data. So you can't do those until you have everybody's data in. Then you can ask that question, answer that question by looking at all the data and go back to your predictions. So you can go back to your predictions, see which one you chose, and talk about that. And what happened? You know, that's another thing is, yeah, we look at our data, we can see what happened, but why? So what's the why behind? Did it increase in speed? The more books, the higher the ramp. Did it slow down? Science, you know, sometimes science is a little wacky. You might see some data, maybe it increased in speed and decreased in speed for some reason. That's okay. That's science. Science does not always come out nice and pretty in a nice little package with a bow on it. Sometimes science is messy. Sometimes the results come out odd and we can't really explain it. So what do scientists do? They do it again. They do their experiments over and over. We're only doing 4 trials here. Most scientists do hundreds and hundreds of trials. So if that comes out strange, if the other data comes in and it's not exactly what we thought was going to happen, that's totally okay. And that's good conversation. Then we can talk about, well, why did it come out? What do you think it came out that way? Maybe find out one of the groups did something. I did a couple of years ago. This happened, and there was a group that was, one thing they were doing is they were pushing the marble. They weren't just letting the marble go down the ramp. The person rolling the marble actually gave it a little extra force. So when their data came back, we're like, wow, why is it? Came out a little different. So things like that, or they were using a different ruler or a different size marble, or they were rolling it on a different surface. So all those pieces can affect your data and the validity of your data. So you'll answer those questions when you get all your class data in there. And then here's a cool little question in the end. Besides changing the height, how else could you increase the speed of the marble? So what else could you do? Let's say you just kept the ramp at the same height. You don't change the height, but you change something else. So that would be a totally different experiment. So what else could you change to increase the speed of the marble if you just kept the ramp the same height? So besides changing that ramp. So just a little extended thinking there for yourselves. So very cool. The biggest thing is we want you to understand that what these numbers mean and how they relate to speed. So very cool that we can see what these numbers means. So 25 centimeters per second, what does that mean? That means for every second, which was about 4 seconds, the marble was traveling what? 25 centimeters. So it was covering a distance of 25 centimeters about every second. That's what that means. So think about when you're in a car, if you're going 60 miles an hour, that means you're covering a distance of 60 miles within an hour. And obviously that number will change because hopefully you're learning about acceleration, that things do speed up, slow down, and also change direction. And that could affect your data here too. Your acceleration might change. You might have your marble might not go straight. It might curve and go a different direction, or hit something and go a different direction. So there's all sorts of other things that could happen. So your acceleration and your velocity could change when you're rolling your marble down the ramp. So many different factors. All right. Well, have some fun, get your data done, and have some good conversation about speed. And we will see you next time. Have a good day.